Good morning and good afternoon, everyone. My name is Chai Chin. Today I will be presenting my project entire photonic sensor network for AI data center and cooling optimization and energy efficiency. So this project focus on fiber backer getting FPG optic sensor together with artificial intelligence to improve the temperature monitoring and optimizing the cooling system in a modern AI data center. The rapid advancements of artificial intelligence AI, cloud computing, and high-performance computing (HPC) have significantly increased the demand of computation resource, leading the next rapid adoption of data center worldwide. So, the modern AI data center contains 1,000 of high-performance graphic processing unit (GPU) and a central processing unit (CPU). This which generate a substantial amount of heat during the continuous operation. So to ensure the reliability system performance and prevent hardware failure, efficient thermal monitoring and the cooling system are very essential. First, for the problem statement for this project is to reduce the increasing energy consumption for AI data center cooling caused by the high density computing workload and the growing demands of computational resource. Then the second is to investigate the limitation of a conventional electronic system temperature monitoring system in providing an accurate, continuous, and a real thermal distribution of high AI server rack. So lastly, to investigate the challenge of achieving energy efficiency and a sustainable thermal management in the AI data center while maintaining the reliable system performance and minimizing the environmental impact. So for the SDG overview, the purpose of fiber backer getting FPG based on thermal monitoring system support the server United Nations Sustainable Development Goal, which is SDG. So for this project, we will particularly focus on SDG 7, affordable and clean energy by improving the cooling efficiency and reducing electricity consumption in AI data center. Then we have also the SDG 9, industry, motivation and infrastructure by integrating advanced photonic sensing technology with intelligent thermal management to enhance the reliability and sustainable for the digital infrastructure. So lastly, we also have SDG 12, responsibility, consumption and production by optimizing the use of cooling resource and extending the operation lifespan for computing equipment. So for the key technology and theory, the FPG is one of the most widely used optic sensing technology for temperature monitoring. And FPG consists of periodic variation in the refractive index inside the core and the optic fiber, forming a wavelet or a selective reflector. When the surrounding temperature change, the reflector FPG wavelength shift due to the thermal expansion and change the refractive index of the fiber. So this is a formula for the FPG, which is 2NEA. So we have the backer wavelength and the effective radiative index of the fiber core in the gating period of the FPG. So the refractive backer wavelength depends on the both refractive radiative index and the spacing between the adjustment gating. Any change of the two parameters could cause the external temperature or sustain will result a measurable wavelength shift. So you can see the formula is below. So we have the backer wavelength shift and the thermal expansion coefficient of the optic fiber, and we add the thermal optic coefficient, then we have the temperature change, then we can get the adjustment gating. So this is the purpose of system design. So firstly, the heat generated by the air server will be get the result from the fiber FPG sensor. Then from the board brand light source, then we will continue to the optical integrator. Then integrator will go to the temperature data processing. Then after the temperature collect, then the AI thermal periodic model will start analysis. Then we go to the intelligent cooling control. Then we have the ARC liquid cooling system, which can help to reduce the temperature. Then after that, we will have the real-time monitoring dashboard to So for the component we use in this project, have broadband light source with the BLS, and the fiber getting sensor with the FPG and the optic fiber, and the optic circulator, optic integrator, and the AI thermal prediction module, and lastly we have the cooling management system for this AI rack. So come to the system operation. So the purpose of FPGA-based thermal monitoring system consists of several optical sensing and signal processing and cooling management component. Each of component perform a specific functional to enable the accurate temperature monitoring and integrated cooling operation in the data center. So first we have the FPG gateway sensor. The FPG sensor are the primary sensing the element used to measure the temperature inside the AI server rack. So each FPC sensor contains a periodic reflected index cabling that reflects a specific value of light. When the surrounding temperature is changed, the reflecting vector wavelength shift proportionally, allowing the accurate temperature measurement at each sensing location. Then next we will go to the optic signal encryption. So firstly we use the optic circulator is the passive optic device that directly the proportion of light within the sensing system. It allows broadband optic signal from the light source to enter the optic fiber while simultaneously directing the reflector vector wavelength from the FPG sensor toward the optic integrator. So the optic integrator is the central signal query unit for the FPG sensing. It measures reflected vector wavelength from each FPG sensor with a high precision and convert the wavelength shift into a digital temperature data. So the integrator continually acquire the real-time sensing information for further analysis and monitoring. So number 3, we will go to the thermal data processing. So the AI thermal prediction module will analyze both history and real-time temperature data using machine learning algorithm. A definition abnormal thermal pattern predict the hotspot formation and estimate the future temperature trend. Yeah, then from the next we will go to the intelligent cooling control system. The cooling management system receive a control signal generated by the AI prediction module depending on the thermal condition from AI data center. It dynamically adjusts the cooling resource such as CERAC unit or the liquid cooling system to maintain the optimal operating temperature while minimizing unnecessary energy waste consumption. So for the expected result and impact, firstly we can accurate the real-time temperature monitoring of the multiple FPG. So the multiple FPG sensor continually monitor the temperature at different locations within the AI rack server. So it enables the early detection of abnormal temperature increase before the overheating occurs. So next come to the improved cooling efficiency. AI analyzes real-time temperature data and predict a potential hotspot formation. The cooling resources are adjustable dynamically based on the actual thermal condition instead of operating continuously at the maximum capacity. Then we also can reduce the energy consumption. Still, the low electric usage lead to the reduced operation cost of AI data center. This can help this intelligent cooling optimization minimize the unnecessary cooling operation. Next, we also can enhance the system reliability. Continuous monitoring help maintain a stable operating temperature for the server. It also reduces risk for hardware failure and unexpected system downtime. And lastly, it also have a longer equipment lifespan. It can prevent excessive heat, reduce the thermal stress on the GPU, CPU, and other critical components. So this can extend the service life for data center equipment by lowering the maintaining the requirement. So for the discussion and future work, firstly the FPG sensor provide or accurate multi-point temperature monitoring to enable predictive cooling system for AI. So this system help to improve energy efficiency and sustainability for AI center, which can help to cooling each of the processing unit. So by integrating the FPG sensoring with artificial intelligent AI, introduce a more intelligent approach to the thermal management or cooling optimization for AI. So these are reference I found online as a reference for this project. So these are all from me. Thank you everyone.